Hi, I'm John Saladino. I'm a licensed professional engineer in the state of Illinois. I have 32 years experience in the road and bridge building sector of transportation. So literacy in my everyday work means being able to read plans, blueprints, or specifications to build roads and bridges. You have to be able to learn how to calculate cubic yards, square yards, measure different shapes, surveying, so laying out curves in roadways, slopes, all kinds of different types of math are needed in order to fulfill my job. The most beneficial skills in the work that I do are being able to interpret the plans and specifications. When you're out on a job, you need to make sure that it's being built so that it'll function. Sometimes you can draw something up, you can measure it, and have lengths and areas in the plans, but when you get out in the field, not necessarily how it's going to be built or how it can be built. So you have to be able to, when you're in the field, adjust areas or lengths in order to make it fit in the boundaries that you're trying to build the project in. That's an important skill, to be able to interpret the plans and to be able to go through and understand what the designer was trying to do, and then to be able to build it so that it actually works. Symbols and abbreviations we have in plans or blueprints are like stationing. So if you're doing a roadway project, every 100 feet is considered a station. The first 100 feet would be 1 plus 00. If you're looking in the plans and you need to know there's a driveway at station 5 plus 95, you know it's 595 feet from the very beginning. So that's one thing you need to be able to know when you're reading a set of blueprints. The scale, you have to know the scale, so that way you can make sure you're laying it out in the right position where it's supposed to be. A lot of the entry-level personnel first have to learn how to read stationing for blueprints and be able to read blueprints. They have to know the tolerances that the machine can go to, whether or not it's meant to cut to the nearest inch or if it's meant to cut to the nearest 16th of an inch. If you're building a bridge, then everything needs to be down to a 16th of an inch. But if you're building a road out in the country somewhere, then, you know, if you're within an inch, that's pretty good. I think it'd be beneficial at the college level, high school level, to actually have examples of blueprints and plans so that somebody could already learn the terminology before they come out into the field. I use geometry quite a bit in the work that I do day to day, just because I'm having to calculate areas and shapes and volumes. You have a very unusual shape, and you have to break it into shapes that you can measure the volume of the area of. You know, not everything is squares and rectangles and triangles. So when you're out in the field, you have to try to make everything as easy as possible to calculate, and also to make sure you're as accurate as possible. Yeah, one of the things that's changed quite a bit over my career was that when I first started, you had computers, but they were very slow and basically just in offices. And all the equipment that we used were all mechanical. So you had to have operators on the pavers, the milling machines, the earth moving machines, and they had to operate those machines. But nowadays, the equipment that they have is just chock full of electronics. So basically there's a computer screen and the operators will just type in what types of slope they need,